oxidation number for a given element which is present in a compound. So oxidation number is our heading today. So first let me give some examples and then I will deal the oxidation number in detail. Okay. So oxidation number. The oxidation number of hydrogen is +1 and oxygen is -2. So this is the first hint what I want to give you now. The oxidation number of hydrogen is +1 and oxygen is -2. Let me take a compound HCl. Here I am going to find out the oxidation number for Cl. So how to find, let me tell you. First you have to write the oxidation number of hydrogen. It is 1 into, how many hydrogen atoms here? It's only 1 is here. So 1 into 1. So this one denotes the oxidation number. This one denotes the number of atoms. So 1 into 1. I'm moving to the next element. So I have to write plus again. Oxidation number of chlorine we don't know. So let me write it as X, and number of chlorine atom is 1. Which is equal to 0. Later I'll tell you why we are equating this to 0. Now let's do the calculation and find the answer of X. So 1 plus X is equal to 0 and X is equal to -1. So the oxidation number of chlorine is -1. Let me give another example. H2SO4. Here you are going to find out the oxidation number of sulfur. We know the oxidation number of hydrogen, it is +1, and oxidation number of oxygen is -2, but we don't know the oxidation number of sulfur. So how to find? First write 1. 1 is nothing but the oxidation number of hydrogen. And how many atoms are here? There are 2 atoms. Enclose plus, then sulfur oxidation number we don't know, so I am writing X into, how many sulfur atoms there? Only 1. Again plus, oxidation number of oxygen is -2 and the number of oxygen atom is 4, which is equal to 0. So once you do the calculation, 2 plus X minus 8 is equal to 0, X minus 6 is equal to 0, or X is equal to +6. So this is the oxidation number for sulfur. So let me give 2 more examples such that you will get a clear-cut idea. I am taking nitric acid, HNO3. Now you have to find out the oxidation number of nitrogen. Because we know the oxidation number of hydrogen is +1, oxygen is -2, but we don't know what is N. So let me substitute. So 1 into 1, that is number of hydrogen atom is 1, plus X into 1, number of nitrogen atom is 1, plus -2 into 3, because the number of oxygen atom is 3 and the oxidation number is 2, equal to 0. So 1 plus X minus 6 is equal to 0, or X minus 5 equal to 0, or X is equal to +5. I am moving to the next example. Let me take H3PO4. The unknown element, the oxidation number should be found out for this phosphorus, because we know the oxidation number of hydrogen and oxygen. Again let me apply. The oxidation number of hydrogen is 1 and the number of atoms is 3, enclose plus X into number of phosphorus is 1, plus -2 into number of oxygen atom is 4, equal to 0. 3 plus X minus 8 is equal to 0. X minus 5 equal to 0. X is equal to +5. So hope I think so you know how to calculate oxidation number of an unknown element in a compound. If the compound contains both oxygen and hydrogen, I think so you are able to calculate. Now I am moving to the next point. Just now I said the oxidation number for hydrogen is +1, except, there is an exceptional case, except hydrides. What do you mean by hydrides? I'll tell you. Before that, if the hydrogen is present in hydrides, the oxidation number is -1. What do you mean by this is, suppose if the hydrogen comes at the back like this, for example NaH, LiH, CaH2, these are called hydrides. So in simply you can keep it in mind, when the hydrogen comes to the right side of the compound, these are known as hydrides. If the hydrogen comes on the right side, instead of +1 you have to substitute the oxidation number as -1. Okay, let me give an example. This is a fifth example. Let me take NaH. Okay, so here we don't know the oxidation number for sodium, so X into 1 plus -1, if it is not +1, -1, because here the hydrogen is in the form of hydrides. -1 into 1 equal to 0, X minus 1 equal to 0, and X is equal to +1. So the oxidation number of sodium is +1. Let me take another example, CaH2. Here I am going to find out the oxidation number for calcium. So X into 1 plus, here the hydrogen is in the form of hydrides, then you have to write -1. -1 into 2 equals 0, X minus 2 equals 0, X is equal to +2. So in all the compounds, the oxidation number for hydrogen is -1. For all the compounds, the oxidation number for hydrogen is -1, except hydrides. I'm sorry, the oxidation number of hydrogen in all the compounds is +1, except hydrides it is -1. Okay, next I am moving to the oxygen. So in all the compounds, the oxidation number for oxygen is -2. It is -2, except there are 4 exceptions. Let me tell all the 4. Whereas hydrogen, it is only 1 exception, whereas in oxygen we have 4 exceptions. What are they? If it is in the form of peroxide, if it is present in peroxide, then the oxidation number is -1. The next one is, if it is in the form of superoxides, then the oxidation number of oxygen is -1/2. Then if it is in the form of that is the compounds of fluorine, OF2, like that, then it will be, the oxidation number will be +2. So these are the 3 options. In peroxide, let me give an example for peroxide. It ends with O2. Okay, peroxides, then the oxidation number of oxygen is taken as -1. It is not -2, it is -1. Superoxide, for example KO2. Here the oxidation number for oxygen is -1/2, whereas in OF2, the oxidation number is +2. So these are the 3 exceptions for oxygen. So let me write one by one. So this is our 7th example. First let me take hydrogen peroxide. So peroxide means it ends with 2. Here I am going to find out the oxidation number for hydrogen. For hydrogen I am going to find. So how to write? Already we know oxidation number for hydrogen is +1. It's okay. Let me find out. X into 2. We don't know the oxidation number of hydrogen, plus, since oxygen is in the form of peroxide, the oxidation number of oxygen is -1. -1 into 2 equals 0. 2x minus 2 equals 0. 2x is equal to 2 and x is equal to +1. So already we know the oxidation number for hydrogen is +1. It's proved. Let me take one more peroxide. Let me take barium peroxide. The formula for barium peroxide is, 8th example, it is BaO2. Now we are going to find out the oxidation number for barium. X into 1 plus, it is not -2, you have to write -1. -1 into 2 equals 0. X minus 2 equals 0. X is equal to +2. So this is the oxidation number for barium. Next I am going to the next option, that is superoxides. Superoxide. So here the example is KO2. Let me find out the oxidation number for potassium. So X into 1 plus, for superoxide the oxidation number is minus half. So minus half into 2 equals 0. So X minus 1 equals 0. X equals plus 1. Next, let me go to the compounds of fluorine. That is your 10th example, OF2. Here we are going to find out the oxidation number for fluorine. Here the oxidation number of oxygen is plus 2. So I am taking 2 into 1, number of oxygen atom is 1, plus X into 2 equals 0. So 2 plus 2 plus 2x equals 0, or 2x is equal to minus 2, or x is equal to minus 1. So this is the oxidation number for fluorine. So students, till now what we learnt is, in all compounds the oxidation number of hydrogen in all the compounds is plus 1 except hydrides. How to identify hydrides is, the hydrogen will come at the right side. Okay, that is known as the hydrides, and it is minus 1. Whereas oxygen in all of its compound is minus 2, and we have 3 exceptions. One is peroxide, it is minus 1. Superoxide, the oxidation number of oxygen is half, and in compounds of fluorine the oxidation number is found to be plus 2. Next, we are moving to the next concept. So you have completed hydrogen and oxygen. So let us recall once again. So for hydrogen it is plus 1, except hydrides it is minus 1. So minus 1 is only for hydrides. In oxygen it is minus 2, except peroxides. If it is a peroxide, minus 1. If it is a superoxide, it is minus 2, and it is plus 2 for compounds of fluorine. Compounds of fluorine, mainly OF2. Okay, so up to this we have done with the oxidation number. Again, I am moving forward. Let me move to few more rules. So here, next point is, oxidation number for fluorine is always minus 1. It doesn't have any exceptions. So fluorine, the oxidation number is minus 1. So let me have some examples. SiF4. Now we are going to calculate the oxidation number of Si. So Si x into 1 plus, for fluorine it is minus 1. Minus 1 into 4 equals 0. So x minus 4 equals 0. X equals plus 4. So plus 4 is the oxidation number for silicon. And let me have one more example, very simple example, HF. So for hydrogen we are going to calculate x into 1 plus minus 1 into x, minus 1 into 1 equals 0. X minus 1 is equal 0, x is equal to plus 1. So we already know the oxidation number of hydrogen is plus 1. Again, I am extending the rules. In periodic table, how many groups are there in the periodic table? Actually, there will be 18 groups, 1 to 18, right? 1 to 18 in the periodic table. The first group elements are called alkali metals. They are called alkali metals, and the second group elements are called alkaline earth metals. So the first group metals are called alkali, and the second group metals are known as alkaline earth metal. The detailed study of periodic table we will be learning in unit 3. Now coming to the point. For alkali metals the oxidation number is plus 1. For alkaline earth metals the oxidation number is plus 2. So let me give some examples for alkali metals and alkaline earth metals. Lithium, sodium, potassium. Whereas for alkaline earth metals it is beryllium, magnesium, calcium. Now let me extend this box. So for first group elements it is +1, for second group elements it is +2. So now let's see some examples which has alkali and alkaline earth metals. For example, okay, KMnO4. Here this potassium is an alkali metal, and Mn we don't know, only for Mn we are going to find out. So this is +1, and oxygen is in the normal compound, so it is -2. This is -2, this is +1, and we don't know the oxidation number for manganese. So let me substitute 1 into 1 plus x into 1 plus -2 into 4 equals 0. So 1 plus x minus 8 equals 0, x minus 7 equals 0, or x is equal to +7. So students, don't forget to put that positive sign. +7 is the oxidation number for manganese. Okay, the next let me give few more examples. NaSO4. Here we are going to calculate for sulfur. So sodium belongs to alkali metals, that is the first group elements. So the oxidation number is +1. Oxygen is -2. Let me substitute 1 into 1 plus x into 1 plus -2 into 4 equals 0. So 1 plus x minus 8 equals 0, x minus 7 equals 0, x equals +7. So let me move one more example using the second group elements. Magnesium hydroxide. Here students, you have to keep it in mind, you have 2 oxygen and 2 hydrogen because it is written OH twice. Now we are going to calculate for magnesium. Okay, we don't want this example, let me some other example. MgCl2. Okay, so we are going to find out the oxidation number for chlorine, because for Mg we already know it belongs to alkaline earth, it is +2. So this is +2, and we don't know about chlorine. So very simple, 2 into 1 plus x into 2 equals 0, 2 plus 2x equals 0, 2x equals -2, x equals -1. So the oxidation number of chlorine is -1. And the next example, CaCO3. You are supposed to find out the oxidation number for carbon. For calcium, since calcium belongs to second group, the oxidation number is +2. So for this I am going to write +2. Here it is x, whereas for oxygen it is -2. Let me substitute now. 2 into 1, because number of calcium atom is only 1, plus x into 1, number of carbon atom is also 1, plus -2 into 3, because oxygen is 3, equals 0. 2 plus x minus 6 equals 0, x minus 4 equals 0, x equals +4. So this is the oxidation number for carbon in calcium carbonate. And now, so once again let me recall the rules what is been framed to identify the oxidation number. For hydrogen, the oxidation number in all the compounds is +1, except hydrides, it is -1. Oxygen, the oxidation number in all of its compounds is -2, except 3 options. One is peroxide, it is -1, superoxide -1/2, and then in compounds of fluorine it will be +2. Then come back to fluorine, it is always -1. These 3 are in the same category. For fluorine it is always -1. For first group elements, that is alkali metals, will be always +1. Second group elements, that is alkaline earth metals, will be always +2. Next I am going to show you an example. You must tell me what is the difference between the compounds what we saw till now and what we are going to see now. Okay. So here I am taking CO3 2 minus. So this comes under ions. They are nothing but ions. Till now we saw molecules. So all these are molecules. All these are molecules. They don't carry any charges. Whereas here these species carry charges. In this case, how to calculate the oxidation number of a given element? For example, if I want to calculate the oxidation number of carbon, the same procedure only. Carbon we don't know, so X, number of carbon atom is only 1, enclose, plus oxygen it is minus 2, number of oxygen atom is 3, and this equals the charge of the ion. That's the thing what you have to keep it in mind. Whereas here in molecules we used to equate to 0. The reason is all molecules are neutral. They are neutral and their charge is 0. That's why the algebraic sum of these oxidation state of all the atoms in a molecule is equated to 0, because the charge over the molecule is 0. Whereas in case of ions, this algebraic sum of the oxidation number of all the atoms in a molecule will be equal to the charge of the ion. So it is minus 2, the same type of calculation. X minus 6 equals minus 2. X is equal to 6 minus 2, which is equal to plus 4. Let me take another ion, SO4 2 minus. Here X into 1 plus minus 2 into 4 equals minus 2. X minus 8 minus 2 and X equals plus 6. Okay, girls. And let me give few more examples. NH4 plus. Here we are going to calculate the oxidation number for nitrogen. For nitrogen it is X and the number of nitrogen is 1. Here the hydrogen is in the form of hydrides. So I have to take the oxidation number as minus 1 into 4 equals, if it is given plus, it is nothing but plus 1. It is plus 1. So X minus 4 equals plus 1. So once minus 4 goes to the other side, it becomes plus 4. So the answer is plus 5. That's all. Another example, Cr2O3 2 minus. Now for chromium, we don't know the oxidation number, but the number of chromium atom is 2, plus oxidation number of oxygen is minus 2, number of atom is 3, equals the charge over the ion, it is minus 2. 2x minus 6 equals minus 2, 2x equals 4, x is equal to plus 2. So this is the way how to find out the oxidation number of an element which is present in an ion. It is very simple. You have to add all the algebraic sum of their oxidation state and it must be equal to the charge over the complex. The next category is, I am going to move how to find out the oxidation number for elements. Till now we found molecules, ions. So we have calculated for molecules. In molecules, all the summation must be equal to 0. In case of ions, all the summation must be equal to their charge. Now I am going to come to elements. For example, if it is an element, for all elements, that oxidation number is found to be 0. Okay, for example, if I take sodium, then the oxidation number is 0. It is an element, right? If I take what is another element, phosphorus, the formula for phosphorus is P4, but the charge over the phosphorus is 0, so it is an element. Compound means two or more elements combines to form the compound. These are all nothing but the elements. Let me take copper. Copper is an element, so the oxidation number is 0. And then sulfur will be SA8. The formula for sulfur is SA8 and the oxidation number is 0 because it is in singly placed, so it is 0. Then I am moving to non-metals. For example, hydrogen gas H2, again this is equal to 0. Chlorine, because chlorine formula is Cl2, it is in the form of molecule, X is equal to 0. Again Br2, N2, for all these things the charges is nothing but 0, So their corresponding oxidation numbers is also equal to 0. Next I am coming to monoatomic ions. What do you mean by monoatomic ions? Is this ion is made up of by only one atom. For example, Na plus. This ion contains only one atom. This is known as monoatomic ion. In case of monoatomic ion, the oxidation number will be equal to the charge. For example, Na plus, so X is equal to plus 1. S 2 minus, X is equal to minus 2. And then O 2 minus, X is equal to minus 2. Al 3 plus, X will be equal to plus 3. So I think so you can understand this to calculate the oxidation number, and these rules are put together. I'll show you the PPT. Just a minute. Okay. So this is the PPT what I'm going to post, and you have to follow this PPT. First, redox reactions. Let me come later to this concept. Now I'm moving to the oxidation number. So what is oxidation number? It is an imaginary charge left on an atom. Let me take an example. If I take H2SO4 and I'm asking to calculate the oxidation number of sulfur, then what you must know is you must know the oxidation number for hydrogen as well as the oxidation number of oxygen. So imaginary charge, the imaginary charge left on an atom when all the other atoms, what are the other atoms? Oxygen and hydrogen of the compound have been removed in their usual oxidation state. Has been removed as their usual oxidation state that are assigned according to a set of rules, and this imaginary number is known as the oxidation number. And in term oxidation number will always be replaced by the word oxidation state, and these are the rules. The oxidation state of a free element is 0, that is if it is an atom, each atom H2, Cl2, Na, S8, for all this the oxidation number is 0. In case of monoatomic ion, the oxidation state is equal to the net charge of an ion. For example, Na plus means plus 1. For chlorine, the oxidation number is minus 1 if the ion is Cl minus. Then, this is the very important one. The algebraic sum of oxidation state of all the elements in a molecule is equal to 0, while in ions, it is equal to the net charge of the ion. And they have calculated for sulfuric acid. So summation of the oxidation state will be equal to 0. And here, if it in case of ions, it will be equal to their charge over the complex. And the next one is hydrogen oxidation number is plus 1 in all of its compounds except metal hydrides, it is minus 1. Here you can see for HCl, the oxidation number of hydrogen is plus 1, whereas in NaH, the oxidation number is minus 1 because it is a hydride. Next point is a very important one. Fluorine has an oxidation state minus 1 in all of its compounds. It has no exceptions. And coming to oxygen, it is minus 2. Exceptions are peroxide, superoxide and compounds of fluorine, and we have seen all this. So in normal compounds it is minus 2. In case of hydrogen peroxide, that is peroxide format, it is minus 1. In case of superoxide, it is minus half. And compounds of fluorine means it is plus 2. And finally comes for alkali metals. These are few examples for alkali metals: lithium, sodium, potassium. The oxidation states are plus 1. Whereas in alkaline earth metals, calcium, magnesium, the oxidation states are plus 2. So students, you have to learn all the 7 points, the rules which has been assigned to find out the oxidation number, as well as what is oxidation number you have to learn. And these are the examples which has been given in the book. So carbon dioxide, they are asking to find out the oxidation number for carbon. For so carbon we don't know, and number of atoms is 1, it is not represented here, plus oxygen is 2 atoms and the oxidation number is -2. So x minus 4, so x is equal to +4. Like that you check out all the answers. Students, hope I think so you can understand how to find out the oxidation number for a given element in a compound. Thank you, students.